Hello and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. You've joined us on a very eventful day for space fans, Tuesday the 10th of March 2026, and the universe is not holding back.
We genuinely mean that. We have a satellite falling out of the sky today, a meteorite that crashed through someone's roof over the weekend, Congress picking a fight with the space station's retirement plan, the biggest image ever taken of our galaxy's core, a map of the universe from 10 billion years ago, and Jupiter doing something a bit strange tonight.
So strap in. This is Astronomy Daily Season 5, Episode 59, and we are not slowing down.
Let's kick things off with breaking news that literally cannot wait because it's happening today. NASA's Van Allen Probe A is expected to fall back to Earth tonight.
Right, this is genuinely happening as our listeners are tuning in. The spacecraft, which weighs about 600 kilograms, roughly the same size as a small car, launched back in August 2012 and has been silently orbiting Earth ever since it was switched off in October 2019.
And the U.S. Space Force has been tracking it closely. As of yesterday afternoon, they were predicting re-entry at around 7:45 in the evening Eastern Time, though there's a plus or minus 24-hour window on that, though it could happen anytime today or tonight.
Now, before anyone panics, the risk to people on the ground is very low. NASA says the odds of anyone being harmed are roughly 1 in 4,200. Most of the spacecraft will burn up during re-entry, and any surviving fragments are likely to land in the ocean, which covers about 70% of the Earth's surface.
So this satellite was originally designed for just a 2-year mission, studying Earth's Van Allen radiation belts, those invisible zones of charged particles trapped by our planet's magnetic field. But the mission ended up running for nearly 7 years before the probes ran out of fuel.
And here's the interesting twist. Probe A was actually expected to stay up in orbit until 2034. So what happened? Solar activity. The sun has been unusually energetic in recent years, and that's caused Earth's upper atmosphere to expand slightly. More atmosphere means more drag on satellites, and Probe A got pulled down faster than predicted.
The twin Van Allen Probe B is still up there and isn't expected to come down before 2030, so we'll be going through this again in a few years.
The data from these spacecraft is still being used today, helping scientists understand space weather, predict solar storms, and protect everything from GPS satellites to power grids. A proper little scientific workhorse.
And now it's coming home. Keep an eye on the sky tonight.
And while we're in the theme of things falling from space, let's talk about this incredible story from Sunday evening.
Yes, so at around 10 to 7 in the evening, local time on Sunday, the 8th of March, 2026, thousands of people in Western Europe looked up and saw an absolutely breathtaking fireball lighting up the sky. We're talking Belgium, France, Germany, Luxembourg, the Netherlands, all these countries with people outside going, "What on earth is that?"
The fireball lasted about 6 seconds, leaving a glowing trail across the sky before breaking apart. People heard multiple loud booms. That's the sonic boom from the space rock disintegrating in the atmosphere. The International Meteor Organization received over 3,000 reports of sightings.
And here's the remarkable bit. Some of it survived. Fragments of the meteorite, which is what we call it once it hits the ground, came down in the Rhineland-Palatinate region of Western Germany, and one fragment punched straight through the roof of a house in the city of Koblenz.
The largest piece left a hole the size of a football in the roof and landed in an unoccupied bedroom. Nobody was hurt, thankfully, though the homeowner now has a very unusual home insurance claim to make.
Fragments have already been recovered from the area. The Koblenz district of Gulz in particular, which will allow researchers to analyze where this rock came from and what it's made of. ESA's Planetary Defense Team has been working to estimate the size of the original object, and they believe it was just a few meters across.
What's wonderful about this event is how many cameras captured it. There's a network called All Sky 7, dedicated fireball watching cameras run by private citizens across Europe, that caught it beautifully. And of course, dozens of mobile phone videos went viral on social media almost immediately.
Meteorite impacts in populated areas are rare but not unheard of. Germany actually had one in 2002 near the Neuschwanstein Castle, and another in 2023 in Schleswig-Holstein. But this is one of the most well-documented falls in recent European history. Quite the Sunday evening.
All right, let's shift from falling things to things we want to keep up. Big space policy news this week. Congress is making moves to extend the life of the International Space Station.
The NASA Authorization Act of 2026 passed through the Senate Commerce, Science, and Transportation Committee last week with bipartisan support, which is always good to hear. And one of its biggest changes is pushing back the retirement of the ISS from 2030 to September 2032.
So the ISS has been continuously occupied since November 2000. That's over 25 years of humans living in space. It was originally set to be decommissioned and deliberately deorbited in 2030. The plan was to crash it into a remote part of the Pacific Ocean in a controlled reentry.
But Congress is saying not so fast. The concern is that commercial space stations, which are supposed to replace the ISS in low Earth orbit, just aren't going to be ready in time. Companies like Blue Origin, BAST, and Axiom Space are all working on successor stations, but timelines have slipped.
And there's also a geopolitical dimension to this. China's Tiangong space station is fully operational and will keep running well into the 2030s. The bill specifically uses the language of avoiding a gap in continuous human presence in low Earth orbit, and explicitly mentions not wanting to cede leadership to China.
The bill also does something very significant on the funding side. It rejects proposed cuts to NASA's budget and instead allocates substantial funding for fiscal year 2026 and 2027. Programs like the Chandra X-ray Observatory are saved under this bill.
There is a caveat here, though. This bill has passed committee but still needs a full Senate vote, and then the House of Representatives, and then a presidential signature. So it's not law yet.
But it sends a very clear signal about where Congress stands on the future of American human spaceflight. The ISS isn't going anywhere just yet.
Now, let's move from policy to pure science, and this next one is genuinely jaw-dropping.
Astronomers have just released the largest image ever produced by the ALMA telescope, and it's a portrait of the heart of our own Milky Way galaxy.
ALMA stands for Atacama Large Millimeter Submillimeter Array. It's a telescope complex in the high-altitude desert of Chile, and it detects radio waves rather than visible light, which means it can see through all the dust and gas that hides the galactic center from optical telescopes.
The new image comes from a survey called ACES, the ALMA CMZ Exploration Survey, and it maps a region called the Central Molecular Zone. That's the area surrounding the supermassive black hole at the heart of our galaxy, Sagittarius A star, stretching across 650 light-years.
To put that in perspective, the finished mosaic spans an area equivalent to 3 full moons placed side by side in the sky. It was assembled from hundreds of individual observations stitched together like a giant jigsaw puzzle.
And what it reveals is extraordinary. The central molecular zone is filled with this intricate web of filaments, long, thin threads of cold molecular gas, snaking through the region, feeding into dense clumps where new stars are being born. It looks almost like a web or a circulatory system.
The survey also mapped the chemistry of the region in incredible detail, detecting dozens of molecules from relatively simple compounds like silicon monoxide, all the way to complex organic molecules like methanol, acetone, and even ethanol. There's a cocktail of chemistry going on near the center of our galaxy.
The team involved was enormous. Over 160 scientists from more than 70 institutions around the world. And they say this is just the beginning. An upcoming upgrade to ALMA, plus the eventual arrival of ESO's extremely large telescope, will let them push even deeper into this region.
One researcher put it beautifully. It's a place of extremes, invisible to our eyes, but now revealed in extraordinary detail. We'll have a link to the image in the show notes. It really is something to look at.
From the heart of our galaxy to the dawn of time, our next story is about a brand new map of the early universe.
Researchers have published the largest and most detailed 3D map yet of light from the universe's early history, specifically the period between 9 and 11 billion years ago. That's a time astronomers call cosmic noon, when the universe was producing stars at the fastest rate in its entire history.
The map was created using data from the Hobby-Eberly Telescope Dark Energy Experiment, HET-DEX, which operates from McDonald Observatory in Texas. And the technique used is really clever.
Most cosmic maps focus on individual bright galaxies. They're essentially dot-to-dot maps of the universe. But this team used a technique called line intensity mapping, which instead of counting individual galaxies, tracks a specific kind of light called Lyman alpha radiation.
Lyman alpha light is produced when hydrogen atoms, the most abundant element in the universe, get energized by young, hot stars. So wherever you see that glow, you know there's hydrogen gas and likely star formation happening nearby.
And by tracking that glow across the sky and through time, the researchers were able to build a 3D picture of not just the bright galaxies, but all the dim, faint matter in between them, the cosmic web of gas that connects galaxies together. They called it a sea of light.
The data set they used was enormous. Over 600 million spectra collected by HET-DEX. And here is the staggering part. The team only used about 5% of those spectra for their primary research mission. This is the first time anyone has gone back and mined that remaining data to do this kind of mapping.
What the map lets scientists do is test their computer simulations of the early universe against reality. As one researcher put it, we have simulations of this period, but those are just simulations, not the real universe. Now we have a foundation to check if the physics underpinning those simulations is correct.
It's like having a map of the world for the first time. You can finally compare what you thought was there with what's actually there.
And finally, something you can go outside and see for yourself tonight. Jupiter, the biggest planet in our solar system, appears to be doing something a bit odd in the sky.
If you've been keeping an eye on Jupiter over the past few weeks, you may have noticed it's slowly moving across the stars from night to night, which is normal for planets as they drift against the background of distant stars due to their orbital motion.
But tonight and over the coming nights, Jupiter appears to change direction. This is what astronomers call retrograde motion, and it's been confusing, delighting, and in ancient times mystifying people for thousands of years.
So what's actually happening? Nothing is actually going backwards. It's all about perspective. Earth and Jupiter are both orbiting the sun, but Earth's orbit is smaller and faster. As Earth catches up to and begins to pass Jupiter on the inside track, Jupiter appears to drift backwards against a star background, like how a slower car on the motorway seems to move backwards when you overtake it.
The change is subtle and it happens gradually over many nights, so don't expect to see it in real time. But if you compare Jupiter's position tonight to where it was a few weeks ago, and then check again in a few weeks, you'll see it. Jupiter is high in the evening sky right now, and easy to find as one of the brightest objects up there.
And tonight, there's also a lovely waning gibbous moon in the southern sky, sitting close to the bright reddish star Antares. So there's plenty to look at if you step outside after dark.
No telescope needed for Jupiter, though one will reveal its 4 brightest moons, the Galilean moons, which Galileo himself spotted back in 1610. A pair of binoculars is perfect.
So go look up.
And that is it for today's episode of Astronomy Daily. What a day! Satellites falling, meteorites crashing, space stations getting a reprieve, galaxy portraits, cosmic maps, and a planet doing loops. The universe never disappoints.
If you enjoyed today's show, please subscribe wherever you get your podcasts and share us with a friend who loves space. Find all our episodes and show notes at astronomydaily.io and come say hello on social media. We're at Astro Daily Pod on X, Instagram, TikTok, YouTube, and Facebook.
We'll be back tomorrow with more from the cosmos. Until then, keep looking up.
Clear skies, everyone.